Welcome to this video training of measurement system analysis. I am your trainer Narendra Sharma. The training is courtesy by www.shakehandwithlife.in. What is measurement system analysis? The output of the process when measured has two kinds of variation. One, part-to-part variation, that is true variation. Second one is measurement variation, which is also called variation due to gauge or operator. The combined study of part-to-part variation and measurement variation is called measurement study or measurement system analysis. Hence, measurement system analysis is the analysis of error in measurement introduced by gauge, operator and part. Part-to-part variation. No two parts exactly each other when manufactured by the same machine. This happens because of process variation or true variation by which the part is manufactured. Hence, part-to-part variation or error introduced in the measurement study. Measurement variation or error. Here we have two categories. One is equipment variation. This kind of variation introduced by the gauge or equipment when one operator uses the same gauge to measure the same part repeatedly. This issue is called repeatability error and it is denoted by sigma E. Other category is appraiser or operator variation. This kind of variation introduced by the different operators when measured the same part using same gauge. This issue is called reproducibility error and it is denoted by sigma O. Components of measurement system analysis: resolution or discrimination, measurement error, bias, Gage R&R, linearity, stability, calibration plot, and attribute R&R. Resolution or discrimination. It is the incremental ability of measurement system to discriminate between measurement values. The least possible value that a gauge can measure, on the basis of that the parts can discriminate from each other. For example, if a gauge can able to discriminate 1/10th value, then readings would be 0.02, 0.03, 0.04 and so on. Similarly, for 1/100th value, the readings would be 0.002, 0.003, 0.004 and so on. Measurement error or sigma m. Measurement error is the deviation of observed value from a true value of a part in the measurement. It has two categories. One is repeatability error caused by gauge denoted by sigma E. Second one is reproducibility error caused by operator denoted by sigma O. Measurement error is equal to square root of sum of variances of repeatability and reproducibility error. The mathematical equation can be written as sigma m is equal to square root of sigma e square plus sigma o square. Bias. It is the difference between the average measured value of a part and standard value of that part as shown in figure. Repeatability or equipment variation. It is the issue of random variation in measurements when one operator uses the same gauge to measure the same part several times. The figure shown here. Reproducibility or appraiser variation. It is the issue of variation in average of measurements made by different operators using the same gauge, measuring the same part, comparing with true average. The figure shown here. Gauge R&R. It is the 6 times of measurement error. Mathematically, if measurement error is sigma m, then gauge R&R will equal to 6 into sigma m, where 6 represents the total process variation. Part variation. Part variation is 6 times the variation of average measured value of every part taken into consideration. Mathematically, it can be calculated as 6 into sigma xi bar, where xi bar is the mean of different measurement values of a part. Number of distinct data categories. It estimates how many separate groups of parts the system can distinguish. Mathematically, it can be calculated as the ratio of part variation to gauge R&R multiplied by 1.41. Minimum number of distinct data categories to accept a measurement system is 5. Total process variation. It is the square root of sum of square of part variation and square of gauge R&R. Mathematically, it can be calculated as shown below. Total process variation is equal to square root of square of part variation plus square of gauge R&R. Measurement capability indices. There are 3 indices which must be considered to accept a measurement system. The first one is the ratio of R&R with respect to total variation. This should be less than 10%. The second ratio is R&R with respect to tolerance. This also should be less than 10%. This ratio is considered when the tolerance or specifications of the part is given. The third index is number of distinct data categories. This value will always be equal to or greater than 5. Linearity. Linearity is represented by the linear equation y is equal to ax plus b, where y is the bias and x is the reference value or true value. A is the slope of the line and b is the intercept of the line on y-axis. Linearity can be calculated as absolute value of A or the slope of the line multiplied by 6. The point of zero bias can be calculated as x is equal to minus of intercept of line divided by the slope of the line. A linearity chart is shown here. The stability of a measurement system analysis can be understood as the difference in average of at least two sets of measurements obtained with a gauge over time, say T1 and T2. As we have seen here in the figure, at time T1 we have an average 1 and at time T2 we have an average 2. If there is a difference in average 1 and average 2, then we can say that the system is not stable. Calibration plot. To calibrate the gauge, we prepare a graph between the master value and the observed value of a gauge. The deviation from straight line represents the error of the gauge at that master value, as we have seen in the graph here. Attribute R&R. Attribute R&R is the study of operators' accuracy of repeatability and reproducibility as per standard attribute. It is based on classification rather than measurement, unlike as Gage R&R. It determines the classification of an item, good or bad, okay or not okay, yes or no, etc. Much less work required while evaluating attribute R&R compared to Gage R&R, but it requires critical analysis. All the best. Thanks for watching this video. This is your trainer Narendra Sharma signing off. For more information regarding in-house, open house and individual training, please contact me via call or WhatsApp 09468267324. My website is www.shakehandwithlife.in. You can mail me at shakehandwithlife@gmail.com. Thanks again.